All right, let's dive in. Beam me up, Scotty. You know that line from Star Trek? Everyone's fascinated by teleportation, and, well, you guys found some really interesting stuff for us to dig into today.
It really is captivating, isn't it?
We've got scientific papers, an interview with a spiritual teacher who says he can, get this, teleport by faith.
Oh, wow.
We've even got some information about IBM's work on quantum computing. Should be pretty interesting.
Yeah, definitely a lot to unpack there.
So we're not just here to debunk the sci-fi dream. We're going to, figure out how real quantum teleportation actually works.
Okay.
Explore the connections it has with spiritual experiences, A&D. And this is the fun part. See if there are any hints about where the science might be going in the future.
Yeah, sounds like a plan.
So to start, I think most people think of teleportation like in Star Trek, right?
Right.
Convert matter into energy, zap it across space, and then perfectly reassemble it at the destination.
Exactly.
Makes transporter sound effect.
Yeah. And it's actually kind of funny because, well, quantum teleportation does exist, but it's not about beaming matter.
Not yet, anyway.
Right. Not yet. What's really important to understand is the difference, the key difference, is in what's being transported.
Okay, so what is being transported?
So quantum teleportation focuses on sending the quantum state of a particle.
The quantum state.
Yeah, not the actual physical particle itself. Imagine this. Instead of sending a whole book, you're just sending the information that makes it unique. Like the story, the characters, all the little details.
So instead of beaming a person, we're sending, like, a blueprint of their quantum makeup. Is that what you're saying?
Exactly. And here's the really cool part. Scientists have actually teleported the quantum states of photons.
Photons, those are light particles. Right?
Yeah, light particles. And they've sent them across some pretty impressive distances, over 100 kilometers through fiber optic cables, and get this, from the ground to a satellite over 1,400 kilometers away.
Wait, so hold on. They beamed a photon's information into space?
They did.
That's insane. So we're not beaming people up yet, but we are teleporting the essence of light across the planet.
That's exactly right. And to understand how that's even possible, we need to look at this really strange phenomenon called quantum entanglement.
Okay, this is where I always get a little lost, to be honest.
It's definitely mind-bending.
Two particles, they're linked, and whatever you do to one instantly affects the other, even if they're like light years apart. How is that even possible?
Imagine you've got two dice, but they're like perfectly matched. Every time you roll them, no matter how far apart they are, they always land on the same number.
Okay.
That's basically what we see with these entangled particles. When you measure the state of one, boom, you instantly know the state of the other, no matter how much distance is between them.
But hold on. Doesn't that kind of contradict Einstein's theory that nothing can travel faster than light?
That's a great question. And, well, Einstein is still right. Entanglement does create this, what physicists call spooky action at a distance.
Spooky action at a distance.
I know, right? But here's the thing. It can't actually be used to send information faster than light. That's because the measurements on both sides, they're random. It's not like you're controlling what info is being sent.
So it's like it bends our minds but doesn't break the laws of physics.
Exactly.
Okay, but I still don't get how entanglement makes teleportation possible.
Okay, let's break it down step by step. Imagine we want to teleport the quantum state of, let's say, particle X from, let's call her Alice, to Bob.
All right, Alice and Bob, got it.
So first, they need a pair of these entangled particles. We'll label them A and B. Alice keeps particle A and sends particle B to Bob.
So Bob's got one half of this spooky dice pair. What's next?
This is where things get a bit tricky. Alice makes a special measurement on both her entangled particle A and the particle X she wants to teleport. Now, this measurement, it actually entangles those two particles. Imagine she has two boxes, one with a cat and one with a dog. She mixes them up. Now, each box has a blend of cat and dog traits.
So she's kind of scrambling the original state of X, but like encoding it into this entanglement.
Yeah, you got it.
But how does that information get to Bob?
This is where good old-fashioned communication comes in, the kind that's limited by the speed of light. Alice sends a message to Bob telling him the outcome of her measurement. It's important to note that this message, it doesn't describe the state of X itself. It just tells Bob what he needs to do to reconstruct it on his end.
So Bob's got his entangled particle, which is now somehow connected to X, and he's got instructions from Alice on how to decode it.
Exactly. Using that message and his entangled particle B, Bob can rebuild the original state of X over on his side. It's like Alice gave Bob the recipe and ingredients, and he can bake the exact same cake, just in a different location.
Okay, I think I'm starting to get it. So we're not teleporting the cake, we're teleporting the recipe, the information that makes it unique. But what happens to the original cake, or in this case, the original particle X?
Here's another really cool thing about quantum teleportation. The original state of X, it gets destroyed during Alice's measurement. It's not copied, it's really truly transferred. And neither Alice nor Bob actually knows what the state of X is. They just transfer it blindly.
Whoa, they're teleporting information without even knowing what the information is. That's crazy.
Huh.
So, okay, if we're only teleporting information and not matter, does this mean we're any closer to beaming people up? Could we teleport the quantum state of a person?
Now, that's the million-dollar question, isn't it?
Yeah.
Sadly, beaming people up, it's still in the realm of science fiction for now.
Yeah, I figured as much. Why is that? What's stopping us from, scaling up this photon teleportation to something more, well, human-sized?
Well, just imagine trying to entangle not 2 photons, but the trillions and trillions of atoms that make up a human being.
Yeah, that's a lot of atoms.
It's a level of complexity that's just way beyond what we can do right now.
Are there any other roadblocks?
Even if we could do that, there's this thing called decoherence. Quantum states, they're super fragile. Any little interaction with the environment, heat, light, even stray cosmic rays, can mess up the entanglement and scramble the information.
So it's like trying to bake a souffle in a hurricane.
Haha, yeah, that's a great analogy. Keeping something as big and complex as a person perfectly isolated from the environment to prevent decoherence, it's basically impossible with our current technology.
So it's like a double whammy, incredibly complex entanglement, and this need for perfect isolation. That's a tall order.
It is.
But scientists aren't giving up, are they? There's got to be some progress happening.
Oh, absolutely. While beaming up is still sci-fi, researchers are making incredible strides. They're teleporting increasingly complex quantum states now, like things called squeezed light beams.
Squeezed light beams. What are those?
So in a squeezed light beam, one specific property of the light is super precise. It's pretty fascinating.
Sounds like it. But before we get too deep into the weeds on that, let's switch gears a bit. You brought this interview with Dr. Bruce Allen, a spiritual teacher, who talks about translation by faith. What is that exactly?
So Dr. Allen describes it as a kind of spiritual travel. People feel like their consciousness is going to distant places without their physical body actually moving.
Okay, so definitely not the same as quantum teleportation. But you mentioned there were some interesting parallels.
There are. Dr. Allen talks about it being the consciousness that travels, not the physical body.
Uh-huh.
And that's a lot like how in quantum teleportation, we're focusing on transferring information, not matter.
Oh, that is interesting. What about those thin places he mentions? Those spots where the spiritual and physical worlds seem to overlap.
That actually kind of echoes the interconnectedness we see in entanglement. If 2 particles can be linked across vast distances, maybe there are, deeper levels of reality where consciousness can connect in ways we don't quite understand yet.
Wow, that's getting pretty deep. Could Dr. Allen's experiences be tapping into some sort of, quantum weirdness?
It's definitely tempting to try and connect scientific and spiritual concepts directly, but we have to be cautious. It's definitely thought-provoking, though. It makes you wonder, are there things about consciousness that operate outside the rules we currently understand?
Big questions. Speaking of big questions, how does IBM's work on quantum computers fit into all of this? What's the connection to teleportation?
Oh, this is where it gets really interesting. So quantum computers, they use these things called qubits, which can exist in a state of superposition.
Superposition.
Which basically means they can be both 0 and 1 at the same time.
Sounds familiar. Kind of like those entangled particles we were talking about, right?
Exactly. And just like we can teleport entangled states, researchers believe we could use quantum teleportation to transfer these qubits between processors and a quantum computer, or even across a future quantum internet.
A quantum internet. Now we're back in sci-fi territory.
I know, right? But it makes sense. If we can teleport the building blocks of quantum information, it opens up incredible possibilities for, computing and communication.
And it gets even crazier, right?
It does.
Because researchers are finding that quantum teleporters, they're not just a way to move stuff around. They're like a fundamental part of how more complex quantum computers could work.
That's right.
So teleportation isn't just a feature, it's like essential to how these computers function.
Exactly. Which is why understanding quantum teleportation is so important. It's not just a cool scientific trick. It could be a key part of the next big technological revolution.
We've gone from beam me up, Scotty,
Yeah.
to teleporting photons in space, exploring potential links to spiritual experiences, and now quantum computers.
Yeah.
My head is spinning. This is way more complex than I ever imagined.
It is a lot to take in, but that's the beauty of these deep dives. We get to explore the edges of what we know and think about the incredible possibilities that are out there.
Totally.
Hmm.
And I think there are even more possibilities than we've talked about so far. Like, what if we're thinking about teleportation too narrowly?
How do you mean?
What if it's not just about moving things from one place to another? Could it be a tool for creating things or manipulating things or even understanding the very fabric of reality itself?
That's a really interesting thought. Welcome back. Hopefully you've had some time to, I don't know, digest all that mind-bending information about teleportation.
Digest. I feel like my brain is doing more of a quantum two-step, trying to keep up with all these crazy concepts. But there was something Dr. Allen said that really stuck with me.
Yeah.
He claims that the ability to teleport, get this, will become normal Christianity in the future. That's a pretty bold statement, don't you think?
It definitely is. And it kind of highlights that this isn't just a discussion about, whether we can do it scientifically. Teleportation, it touches on some really deep beliefs we have about who we are, about the nature of consciousness, maybe even about the very fabric of reality.
You're right. If we ever could teleport people, and that's a big if, what would that mean for our sense of identity? If the original is destroyed in the process, is the reconstructed person really the same person?
That's a question that philosophers have been grappling with for centuries, long before we even started talking about quantum teleportation. It's like the classic ship of Theseus paradox. If you replace every part of a ship, is it still the same ship?
And in the case of teleportation, we're not just replacing parts, we're creating a perfect copy from scratch. Does the soul get teleported along with the information? What about memories, experiences, everything that makes us, well, us?
Those are questions that, unfortunately, science can't answer right now. They bring up these huge ethical questions we'd need to figure out if human teleportation ever became, real thing. Would it be murder, suicide, or something else entirely?
And even beyond the philosophical questions, there are practical concerns too, right? Like, what if something goes wrong with the system? Do you end up as a jumbled mess of atoms on the other side? Or even worse, what if someone could hack into the teleportation stream and make duplicates?
Exactly. Security and reliability would be absolutely critical, and we can't ignore the potential for misuse. Imagine if terrorists could teleport bombs into secure locations, or if governments used it for, surveillance or even assassinations.
Suddenly, beam me up, Scotty. Doesn't sound so fun anymore. It's like we might be opening a Pandora's box.
Having these conversations now, while the technology is still in its early stages, is so important. We need to really think about the ethical and societal implications and put safeguards in place before things go too far.
I totally agree. And that's what makes these deep dives so important. It's not just about the cool factor of the science. It's about understanding the impact it could have on humanity as a whole.
Well said. And amidst all these potential risks, we can't forget the incredible possibilities that teleportation could unlock. Imagine a world where travel is instant and sustainable. No more cars, planes, all that pollution.
And the medical applications could be amazing. We could teleport organs to people who need them. No more waiting lists for transplants. Maybe someday we could even teleport medicine directly to diseased cells inside the body.
The potential is limitless, really. But achieving that depends on overcoming those massive technical hurdles we talked about earlier, creating and maintaining entanglement on a large scale, dealing with decoherence, and developing technology that's precise and reliable enough to teleport something as complex as a living being.
It sounds like we're a long way off, but it's exciting to think about what the future might hold.
Yeah.
There's one aspect of teleportation we haven't really touched on. What about teleportation and time travel? Is there any scientific basis for that, even in theory?
Now we're getting into truly uncharted territory. There are some theoretical ideas, like certain interpretations of wormholes, that suggest time travel might be possible under extreme conditions. But combining that with teleportation, that takes us into a realm of pure speculation. Even the most brilliant physicists are careful about going there.
So beaming ourselves into the past or future is even further out there than just beaming across space.
For now, yes. But remember, just a century ago, the idea of teleporting even a single photon would have sounded like pure fantasy. We're constantly pushing the boundaries of what we think is possible.
I'm sensing a theme here. Every time we think we're getting a handle on quantum mechanics, it throws us another curveball. But that's also what makes it so fascinating, isn't it?
Absolutely. It reminds us that we're always discovering new things about the universe and our place in it. And as we dig deeper into these quantum mysteries, who knows what other mind-blowing possibilities are waiting to be uncovered.
All this talk about quantum possibilities is making me think, could there be other ways to use teleportation that we haven't even thought of yet? Something beyond transportation, communication, even computing. What if? What if what if we're thinking about teleportation too small?
Too small.
Like too practically? What if it's not just about moving stuff from point A to point B? What if it's a tool for, creation or manipulation, or even understanding the very fabric of reality?
That's a pretty profound thought. We tend to think of it in terms of, the practical applications, transportation, communication, computing. But yeah, there could be applications we haven't even dreamed of.
Right. Like what if instead of teleporting an object, we teleported the quantum state of one atom onto another atom? Would we be transmuting elements?
It'd be like alchemy, but on a quantum level.
Exactly. Or what if we could teleport the state of a healthy cell onto a diseased one?
Wow.
Would that change how we treat diseases?
The possibilities they really are mind-blowing. We're just starting to understand what quantum teleportation might be capable of. But maybe we should, step back for a second and think about what we've learned today. We started with Beam Me Up, Scotty. We explored, the reality of quantum teleportation. We talked about how it could change computing, communication.
Yeah.
We even touched on, the philosophical and spiritual implications.
It's been quite a journey. And we've seen that quantum teleportation, it's not just science fiction anymore.
It's real.
It's a real thing. And while beaming people up is still a long way off, the research is moving so fast, pushing the boundaries of what we thought was possible.
What's really striking to me is how quantum teleportation forces us to change our perspective. It makes us rethink what reality even is. It suggests that information, maybe, is more fundamental than matter itself.
That's a huge idea. And it brings up some pretty deep questions, about who we are, about consciousness, about the soul. If we could teleport a person's quantum state, would we be teleporting their essence, their being?
Those are questions that science can't really answer on its own. They go beyond science into philosophy, spirituality, ethics. It's a reminder that scientific progress often comes with big ethical questions we need to grapple with.
And we need to talk about these things openly and honestly.
Right.
And it can't just be scientists and engineers. It needs to involve ethicists, philosophers, policymakers, everyone, really.
I couldn't agree more. The future of quantum teleportation, and really the future of any new technology, shouldn't be decided by just a small group of people. It requires careful thought, planning, understanding of the potential consequences, both good and bad.
And these deep dives, I think they're a part of that process. It's not just about learning cool new things. It's about giving people the knowledge to understand these technologies, to help shape the future we want.
Absolutely. Knowledge is power. And understanding quantum teleportation with all its amazing potential and challenges is crucial if we want to navigate the future.
As we wrap up our deep dive into teleportation, I want to leave you with this thought. We've seen how this technology, which used to be pure science fiction, is becoming a reality. So who knows what other seemingly impossible ideas might be just around the corner.
The journey of discovery never ends. And with every new breakthrough, we learn more about the universe and our place in it. So keep asking questions, keep exploring, and keep pushing the boundaries of what you think is possible. The future is full of potential.